In this video, I'm going to be talking about proving angle relationships. And there's a lot of postulates and theorems in this video that you need to use and remember. Make sure you write them in your notes because we're going to be using these to justify our reasons in some of our algebraic geometry problems. So the first one is the angle addition postulate. And what we have here is we have, as long as you have a point D that's in the interior of an angle, we have that the measure of ABD plus DBC is going to equal the whole big angle. So, an application of this. First, what I'm going to do is I'm going to read the problem, obviously. Angle CDI is 8x minus 6. What I like to do is I like to write that in there, 8x minus 6. And IDE is 80. So I write that in there. And then they tell me that angle CDE, this whole thing, is 13x plus 14. I just switched those two. The program I use sometimes moves those around. So what you want to keep in mind here is the big angle. Angle CDE is equal to the two smaller angles. So angle CDI plus angle IDE. So the two angles that make up the smaller angle add to be the bigger angle. So now we set up our algebraic problem. So 13x plus 14 is equal to 8x minus 6 plus 80. Now this just turns into an algebraic problem. So on the left side, I have 13x plus 14. On the right side, I have 8x plus 74. I'm going to subtract the 8 over to the left side. Subtract the 14 over to the right side. And then I'm going to divide to get 12. Okay, so the two smaller angles sum up to be the bigger angle. And this is if the angles are what we call adjacent. And we've talked about that. And I think I spelled adjacent wrong. But I don't have spell check on my iPad. Okay, the next thing. If two angles form a linear pair, so if they're adjacent and their opposite sides form a line, their non-common side form a line, then they are supplementary. Just means that they add up to 180 degrees because a line is equal to 180 degrees. And then our complement theorem. If the non-common sides of two adjacent angles form a right angle, then they're complementary. So basically, if I have two adjacent angles here, their non-common sides are perpendicular, or they form a right angle, my two angles are going to add up to 100 or add up to 90 degrees. So find x given each picture. So we have to look here, okay? I have a little right angle symbol. So I know that those two angles add up to 90 degrees. So 5x plus 2 plus 43 adds up to 90 degrees. They're complements. Now, what's my reasoning for that? Let's go back to the last slide. That's my complement theorem. So my reasoning for that is the complement theorem. Now I need to solve this equation. So I have 5x plus 45 is equal to 90. 5x equals 45. X is going to equal 9. And then our theorem or postulate is the complement theorem. Now, example B. We're given line AC. What they're telling me here is they're telling me that this is a line. Okay, so I have two adjacent angles whose non-common sides make a line. So that means they're a linear pair and supplementary. So 2x plus 18 plus 5x plus 1 equals 180. And the reason for that, again, I'm going to go back to the last slide. That's the supplement theorem. So the reasoning is the supplement theorem. So now I combine like terms. I get a 7x plus 19 equals 180. So now I subtract it and get 7x equals 161. And I get x to equal 23. Okay, so those are some applications kind of similar to what you might find in the book for our complement theorem and our supplement theorem. Okay, congruent complements and congruent supplements theorem. These two things are the same, whether your angles are supplementary or complementary. Okay, so angles to the same angle or to congruent angles are congruent, meaning if angle 1 and angle 2 add up to 180 degrees, but angle 2 and angle 3 add up to 180 degrees, then 1 has to equal 3. Kind of a short algebraic proof of this is notice how they both equal 180. Okay, so I'm going to set the left sides equal. So measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. If I subtract those angle 2 from both sides, you get 1 equals 3. Same thing is true for congruent complements theorem. This is kind of it's not a hard theorem, but students I sometimes find kind of struggle with this theorem a little bit. We'll see how we do with the next example. Okay. Find the measure of each numbered angle and name the theorem that justifies my work. Okay. 2 and 3 are complementary, which means that they add up to 90 degrees. So I have a right angle there. 4 and 3 are complementary, so I have a right angle there. So 2 and 4... I should write in 2. They tell me 2 is equal to 38. Okay? Again, the diagrams in geometry are so important. Draw on those diagrams. Write on them. Mark them up. I remember that's what my high school teacher used to say, and I always used to be like, no, I don't want to do it. But trust me, it works. Okay, so since 2 and 4 are complements of the same angle, therefore I know that angle 2 is congruent to angle 4 by our congruent complement theorem. Okay, let's go back to the last slide. Congruent complements theorem. Angles complementary to the same angle. 2 and 4 are complements of the same angle. So if angle 2 equals 38 degrees, then angle 4 has to equal 38 degrees. Okay. And then kind of re-looking at this diagram a little bit. Angle 3 plus angle 4 equals 90 degrees. What's our reason for that? Well, that's I'm going to flip back. complement theorem. So that's our complements theorem. Well, we just said angle 3 plus 38 is equal to 90. So angle 3, when I subtract, I get 52. Okay, so I have a 52 in here. Okay, now all of these angles, let me do this in a different color. Let's do it in pink. Angle 1 plus angle 2 plus angle 3 plus angle 4 equals 180 degrees. Now, technically, that's kind of a version of that supplements theorem. Technically, the supplements theorem is only 2 angles. I would accept it because, quite honestly, you get the idea of the geometry concept I'm testing you on. So I need to find angle 1. We know angle 2 is 38. Angle 3 is 52. Angle 4 is 38 equals 180. So I have 38 plus 52 plus another 38. Okay, and then I subtract from 180 to get angle 1 equal to 52. And there's another concept we could use on this. I'm going to leave that for another time. But that's how you would utilize those congruent complements theorem and congruent supplements theorems. Okay, so the last thing we're going to do is called the vertical angles theorem. Vertical angles, okay. X marks the spot. So you have 2 lines that intersect. They form an X. Vertical angles are those that are across from each other. So angle 2 and angle 4 are congruent. Angle 1 and angle 3 are congruent. Okay, so X marks the spot. So now in this example 4, I have one line here that intersects, another line here that intersects. X marks the spot. Unfortunately, you kind of have to ignore that last one. Let's see, do I have white? I do have white. So if I kind of like write on that in white so it's not there, and you can like maybe cover that up with your finger. So now we have X marks the spot. I have 2x plus 1 equals 89. And how I got that equation is I used the vertical angles theorem. Okay, now I subtract 2x equals 88. X is going to equal 44. And that is my video on proving some angle relationships.